Hello, everybody. We are Andy, Ali, and Anne. We talk about automatic attendance system for the final projects of digital image processing. In this presentation, we will talk about the introduction, methodologies, the coding, result, evaluation, the conclusion, and also the reference. The face recognition is the computer application which can detect, track, identify the human faces from the images or the video capture from the digital camera, and which is a very modern applications in the today world, such as security, access control, identity verification, marketing and advertising analysis, healthcare, education, and entertainment. So these projects we build the automatic attendance system to recognize the faces labeled with their name for a student when they enter and then when they leave the class.
Well, in this slide, you can see our methodology and how our algorithm will work. So as you can see clearly, we have three major parts: input, main function, and output. As an input, we have our reference images and live images from the webcam on real time, and as well as threshold calculation based on the 1 meter range limitation that we have for our methodology and our program. In the main function part, we have used different libraries such as face recognition, CV2, NumPy, and pandas. Later on we will use it pandas. In the face recognition library, it will do the main part of our work, which is recognizing the face. And using CV2, we can convert BGR to RGB type of the image in order to later on apply some modification to our images. So our images could be read as matrices, as you may know, and with that we can do comparison with the help of NumPy. After that, we would end up with a face confidence percentage result. If our face confidence percentage results are beyond our threshold, this means that the person is recognized. For our project, we calculated our threshold to be 60%. So if the face confidence goes beyond 60%, the person is recognized. Otherwise, it would be an unrecognized person, which the output would be 3 question marks, which is the person couldn't be recognized. But after that the person is recognized, there would be a rectangular box around the faces and label their names, as well as checking their first occurrence. I mean, like the first time they enter the class, for example, and it will record the last time that they leave the class as well. And at the end of the day, we have a table of record with the names who, like the students who registered already, their entrance time, their leaving time, and as well as the percentages of the face recognition function.
And for the first part of the code, as you can see in this slide, the face confidence function takes the distance between a detected face and a known face and calculates a confidence value for the match based on a given match threshold. The confidence value is represented by a percentage. In other words, if the detected face is very different from the known face, the confidence value will be low. If the detected face is very similar to the known face, the confidence value will be high. And if the face distance is equal to the face match threshold, the confidence value will be 50%. For the second part of the code, as you can see in the picture, the code checks if the match name is already in the result dictionary. If it is not, a new entry is created with the current timestamp as the start time and end time. And if the name already exists in the result dictionary, only the end time is updated with the current timestamp.
So this slide tests how the algorithm works. So first we have the reference image, as you see for Ellie, Andy, and also me. So then the algorithm will recognize the people in the range of 1 meter and couldn't recognize the people out of the range of 1 meter, as we can see. For a figure 4 in the 1 meter range, the algorithm can recognize Ellie, Andy, and me at the same time with a very high phase confidence, as you see, greater than 95%. And then when I'm out of the range of 1 meter, it couldn't recognize me, but it can recognize Ellie and Andy. And also our algorithm can detect and record the name, the time when the student enter and also leave the class as the table 1.
All right, to summarize our work in the conclusion part, our automatic attendance system using the face recognition library has shown that the potential of this technology in various applications, as we mentioned in the introduction, including the education and healthcare and also the security means. You can clearly see the use of OpenCV and face recognition libraries for face detection, that how easily they could be used, and those are very important tools in these days. But for more modification, we could have used the scikit image as well as a good library. They have a trade-off between OpenCV, so both could be useful. We should see what type of project or problem we have to decide which one works better. This project has shown the importance of pre-processing and face encoding for accurate face recognition. So if we would have had very higher resolution webcams, we could have, for example, go beyond that 1 meter limitation for face recognition that we mentioned before. Also, as a foundation for further research, this project can be expanded with additional features such as graphical user interface or integration with a database to improve its use and functionality. And here are the references we used for our project. Thank you for listening to us.